Right. Um, Good afternoon, class. Sorry I'm a little bit late getting started. Um, I would like to make an announcement about the grade stuff that went out yesterday. That was an April Fool's joke. So just chill out. Some people got the joke, some people didn't, and sent me very serious emails about their grade being destroyed by the extra credit. So don't worry about it. It's been deleted. If you check the grade book now, I deleted the April. I even called it the April 1st extra credit. So, hi Ray, hi Sebastian, hi Ava, hi Ricky. So, anyways, interesting fact. I figured out I can give on an assignment is 9,999 points. That's the most points that an assignment can be worth. Furthermore, I figured out that the most a grade can be weighted was 9,999. Okay, so what I did was I created an extra credit where I created an extra credit where the weight was 9,999 and it was out of 1 point. 9,999 out of 1. So you already got extra credit because you earned 9,999 times the maximum score. And then I weighted it 9,999 times. So you actually got 9,999 squared points added to your grade book. So that's why you had millions of percent in the class. So, and I didn't know I could make the scores negative. That's good to know. I've never tried that before. All right. So today we're going to talk about some circuit intuition. All right. So circuit intuition. So we're just going to kind of use the calculation tools that we've learned to just kind of try to understand circuits, not from the level of calculations, but just kind of from an intuitive standpoint. And in particular, we're going to try to answer the question, which resistor will be hottest? So remember, resistors are taking electrical energy and turning it into heat. Or if these were light bulbs, because remember, a light bulb behaves just like a resistor does. Which bulb will be brightest? Okay, and so the answer to that question is the one that dissipates the most power. Okay, so if a resistor is dissipating the most power, then it's going to be the hottest resistor. If a bulb is dissipating the most power, then it's going to be the brightest. Okay, so the equation for power is IV. All right, and if we use Ohm's law, so if we combine that with Ohm's law, we can write an equation for power that is V squared over R. Examples. And so in all of these examples, what we're trying to answer is this question: which resistor will be the hottest? Okay. And all that matters really is the relative size of the resistors. The size of the battery doesn't matter. It's a voltage divider. And one of the things about a voltage divider is that the two resistors are in series. So according to SIPOV, both of these resistors are going to get the same current. So the current is the same for each of those. So if we look at I squared R, the current is the same for this one as it is for that one. And so the one that's going to be dissipating the most power is the one with the biggest resistance, which is the 2 ohm resistor. And in fact, it would be dissipating twice as much power. So we could say that the power dissipated by the 2 ohm resistor is greater than the power dissipated by the 1 ohm resistor. Okay? So that is a nice voltage divider circuit. Okay? Moving on to the next example, we have a battery and then 2 resistors in parallel. Okay? So it wouldn't really make sense to compare these in terms of I squared R because these 2 resistors have different currents and different resistances. It makes more sense to compare them in terms of V squared over R because they both have the same voltage. So we can see that if 2 resistors have the same voltage, then the one with the smaller resistance is dissipating more power. So between these two, I'm sorry, I'm getting some messages that I'm freezing more than normal. I will just make sure to restart my router before next class period. But there's not much I can do about it right now. I apologize. So these both have the same voltage. So according to P equals V squared over R, the one with the smaller power dissipated by the 2 ohm resistor. Okay? I'm going to do some more examples. So here we have some current flows out of the battery, and it flows through the 2 ohm resistor and the 5 ohm resistor, and then the current splits and goes through each of these 2 parallel resistors. And so what we would like to know is which resistor is going to be the hottest. Okay? Now, if we look at this current, whatever current flows out of the battery, it's going to split between these 2. Okay? So what that means is that these 2 have the most current. They have more current than these 2 because these 2 are basically like tributaries or not tributaries, but just like offshoots of a river. All right. So the main river has the most current. And so these 2 are going to have the most current. So according to I squared R, so the 5 ohm resistor has the most power. It's the hottest. This one has the most current and the second most resistance. So this one would be dissipating the second most power. These 2 have the least current and they have the least resistance. So they are going to be both dissipating the least amount of power. Now it's actually, they're going to dissipate the same power because the current is going to split 50-50 between these 2 because they're equal resistors. So they have equal resistance and equal current. So they will both dissipate the same amount that is less than P2. So that would be a ranking for them. Okay. We'll do one more example here. I goofed here, so you can ignore that. But we have basically a current divider, and you can see that the resistance of this branch is 3 ohms, and the resistance of this branch is 3 ohms. So any current that is going to flow out of the battery is going to be split evenly between this branch and this branch, because each branch has the same resistance. So according to I squared R, all 3 of them have the same current. By the way, these 2 are in series, so they have the same current. So the current comes out, it gets split, 50% goes this way, 50% goes this way. All 3 resistors are going to get the same current. And if they all have the same current, then the deciding factor is the resistance. Resistance, the power dissipated by the 3 ohm resistor is going to be the most. The power dissipated by the 2 ohm resistor is going to be second most. And the power dissipated by the 1 ohm resistor is going to be the least. All right. So I've often seen this kind of a problem on the AP exam. Who knows, on the AP exam this year, you might not see that kind of a problem. But I still thought you should know about it. And I think it's nice to have a little intuition. Tomorrow, we're going to be talking about the connection between circuits and other areas of physics. I hope you have a really good rest of the day, and I hope you weren't too panicked by my April Fool's joke. All right, bye now.